Well, hello there. My name is Abdullah and I am an IGCSE student. And in this video, I'm going to be presenting to you my latest project of 2025, which is the Smart Solar Tracking System. Now, this project is primarily designed to maximize our solar energy capture by automatically adjusting the position of this solar panel here directed towards the sunlight or any light source that hits it, okay? So in this video, we're going to uncover some key factors like what inspired me to make this project, what are the benefits and real-life applications of this project, and are there any disadvantages to this project? If there are, how can I solve them? At the same time, I'm also going to be answering some common questions you might have about this project by the end of this video. So by the end of this video, we will understand that why this idea is so important for us to maintain or achieve a greener, cleaner, and a more sustainable future. Of course, by the end of the video, if you do have any questions about this project, feel free to ask me in the comments below. So what exactly is my project and how does this project work? So first of all, my project here uses an Arduino microcontroller chip. This is a type of CPU chip that is somehow acting as the brain of our system here, because this controls the movement of the solar panel by using LDRs. Now LDR stands for light dependent resistor, and these are types of light sensors, okay? Now by the name light sensor, we can identify that light sensor is something or a type of sensor that detects the light in the environment, okay? Now my light sensors or LDRs that I have been using in this project is designed and programmed to detect where in the environment is the brightest sunlight or light source coming from. So the LDR is going to detect where is the brightest sunlight coming from, and it is going to process this as a signal and feed this information by sending the signal of the brightest sunlight to the servo motor. The servo motor will then interpret the signal received by the LDR about the direction of the brightest sunlight, and the servo motor will then rotate the solar panel to move it in the appropriate direction to track the brightest sunlight for maximum absorption of solar energy and result in maximum output of electrical energy, okay? Now, by the way, this idea or concept of tracking sunlight or tracking the brightest light source actually improves efficiency by up to more than 50% compared to our regular stationary solar panels. Now, if you're wondering what inspired me to make this project, or what was the main idea or source of this project, basically, it was just a sunflower, because this project here basically mimics the idea of how the sunflower continuously changes its direction towards the sunlight to maximize light absorption. And this project here is implementing that same idea of tracking the sunlight like the sunflower, but with the use of smart electronics to help us achieve a more greener, cleaner, and sustainable future. Okay, so now that you know how my project works, let's have a look at all the benefits and real-life applications of my project and why this project is so important for our future, okay? But before I start with that, just so you know, solar energy is one of the most cleanest and most abundant renewable resources out there. However, our traditionally fixed solar panels only capture sunlight at certain times of the day, okay? And this is a big problem because a lot of energy is wasted. So my tracker here solves this problem by tracking the sunlight at every moment of the day to maximize our solar energy capture. So in real life, solar technology has various applications. For example, we can use solar technology in solar farms to increase energy production. We can use solar technology in satellites and space stations with specific sensors to measure quantities for space scientists and astronomers. For example, solar technology is highly used in industries like NASA. And by the way, we can also use solar technology in your home appliances and devices, like calculators as a battery source. Now, if you're wondering why I chose this project specifically, so first of all, just so you know that this isn't my first ever solar panel project, because in last year's global warming event, I actually made a model of a solar panel using cardboard to show how or why solar panels and solar energy is so important for our environment to reduce global warming. And I thought, This year, why not come back stronger and better by enhancing upon my idea last year by making it more practical and better? Now, the second reason I chose this project is because I strongly believe that solar energy is a game changer in our fight against climate change, okay? And there is always room to improve. Because last year, my project was just a stationary solar panel made of cardboard. But this year, I'm coming back smarter and more practical idea of a project with this tracker here to maximize our light absorption and understand and show how we can make solar panels much more efficient. Because remember, in the end, the primary goal is always to do our best to transition ourselves into a more cleaner, greener, and sustainable future. So if you do own or plan on owning one of these solar tracker systems, there is one potential challenge that you should take into consideration here, and I'll also tell you how to resolve that issue. And it is what we call mechanical wear-off. So yes, over time, some parts of the system might begin to wear off, and to solve this issue, two things need to be taken into consideration. First of all, you need to make sure that you are keeping regular maintenance of your system to keep it maintained throughout the year, and make sure that you are using quality motors to keep your system well maintained and regulated. Alright, now this is my project in 2025, but in the near future, this idea can be enhanced much more. So let's have a look at some future considerations that could be implemented on our idea here. First of all, dual axis tracking can be implemented on the project to track the sun more precisely, or AI-based weather prediction. Imagine, we could use artificial intelligence programmed into the solar panel, so not only does it convert solar energy to electrical energy, but it can also detect the weather predictions. Also, we can also use artificial intelligence in the solar panels to maintain or program a self-cleaning system. So we can have self-efficiency of the solar panel without the need of humans to maintain the solar panel. And lastly, my favorite one, and I think this is actually going to be implemented very soon, is IoT connectivity. Connectivity to the Internet of Things. Imagine controlling the solar panel just from your phone. So in summary, my smart solar tracking system here basically shows how automation and smart thinking can both be combined to help us enhance the use of renewable energy and technology to help us move and transition into a more sustainable future. Now, thank you all for your time. Well, I hope this project inspires many more ideas for a more sustainable future for all of us. And thank you so much for watching this video. If you do have any questions about my project, feel free to ask me in the comments below, okay? And if you do want to stick around for 3 more questions that I'm going to answer right now. Now, these are very common questions that I get asked. The first one is that, how scalable is my project? Now, of course, this is just a model, but in real life applications, this project can be used in huge solar farms to produce a large amount of energy, and it can also be used in your household rooftops, okay? Second question, will this project work in rainy, cloudy, or snowy days? Yes, actually, the project is still going to work, but efficiency might be affected or reduced because it produces the actual amount of electrical energy or the maximum amount of electrical energy depending on how much sunlight there is. Now, if there is less amount of sunlight on a cloudy day, then yes, there's going to be minimum absorption and minimum production of solar and electrical energy, okay? The last question is about this project. What if the project fails to work? In that case, whether it's the module itself or we're talking about the real-life applications of this project, the components that make the solar system tracking is actually modular, meaning it can easily be replaced and repaired. So you don't have to worry about that. Alright, so for this last part of the video, I'm actually going to show you how this project works. And I have a flashlight here with me, and I'm actually going to point the flashlight on this project, and let's see how the solar panel will move into its direction towards the maximum sunlight it is receiving. Okay, sorry, not sunlight, flashlight. Alright, so now we're going to open the torch. The torch is open, and let's have a look at how this project is working. So as you can see, as I'm pointing the light onto this project, now the LDR is detecting where is the brightest light coming from. And as it is detecting the brightest light, it is sending a signal to the servo motor, which is located right here, to convert this signal into motion of the solar panel. And the solar panel is moving towards the direction of the light. Let's try to move it a bit more. And we also have a sensor over here that is going to tell us the reading of the light intensity that is being received by the solar panel. So, as you can see, as I'm moving flashlight, the solar panel is actually moving. So let's do it the other way around now. Let's do it backwards, and we're going to make it do a somewhat full degree, 360-degree rotation. Okay, so complete. Okay, let's make it go flat. And there we go, come back. So what's happening here is, again, the LDR is detecting the brightest light and it is converting it into an electrical output, which if I connect a, let's say, charger, it can actually charge and produce an electrical output, which I'm going to show you in the next part. For now, I'm just demonstrating how that it is going to be tracking the light in the maximum light received. There we go. So yeah, that's pretty much the idea of how the solar panel works. As I shot the flashlight onto the solar panel, and as you saw, what was happening is that the solar panel was moving in the direction of the light that I was shooting in, because it detected that this is where the maximum light is coming from. So this is where the solar panel is going to move, in the direction of the maximum flashlight. Okay, now in this last part of the demonstration of how this project is working, the first part I showed you how the solar panel is tracking the light that I'm shooting it at. Okay, now for this last part, I'm gonna show you how this solar energy or light energy is going to be converted into electrical output. So here I have a Nokia with me, and again I'm using a device with low voltage because this is just a model. In large solar farms, or let's say large real-life applications of these trackers, we can use these to power full houses. Okay, so now what I'm going to do is I'm going to open the light and I'm going to be pointing the light onto the solar panel. Okay, now what's going to happen is the solar panel is going to show a reading on the sensor, and it is going to be converting this light energy into electrical output. So I have a charger connected to the solar panel, and I'm going to connect the charger to this Nokia over here, and we're going to see how this solar panel is going to charge this Nokia by converting the light energy into electrical output. So now let's connect the Nokia. So the Nokia is connected, and as you can see, it is charging. Why? Because as I am hitting light to the solar panel, I don't know if it's clear, but the Nokia is charging because the light energy is being converted into electrical output. Okay, now of course for this model I'm using a low voltage like I mentioned, because this model is using a 6-volt battery, but in real life applications we can power full houses with this. Okay, and as you can see right now, the solar panel may not be tracking the light as I am moving it, because the light energy is completely being used right now to be converted into electrical output, so it will have minimal movement at this moment. And yeah, that's pretty much it for the conversion. Again, thank you so much for watching my video. In this video we have talked about my projects for this year, smart solar tracking system. Not only have I explained and talked about my project here, but I've also showed how my project works by not only tracking the light it receives, but also converting this light energy into electrical energy. If you have any questions, feel free to ask me in the comments below, and thank you so much for watching this video, and I will see you in the next one.